Hello, 8th graders. I am here today to teach you about simplifying radical expressions. Yesterday we learned how to simplify radical expressions using the product property of square roots. Today we're going to use the quotient property of square roots. So the quotient property of square roots is, I'm just going to read it directly here from your book. You can divide square roots and simplify radical expressions that involve division by using the quotient property of square roots. For example, here we've got the symbols, and symbols, it's radical A, the fraction AB, the radical AB is the same thing as writing, I'm just outlining it, A, radical A over radical B. Seems pretty straightforward. In numbers, for example, that would be the same thing as taking it's the square root of 49, again I'm outlining in black here, over the square root of 4. Okay. And let's see what this actually means in principle. So if I take a number of the square root of 10 over the square root of 3, this is not in simplified terms. We never want, in this case, if we want to simplify terms, we have to get rid of the square root in the denominator. And to do so, all we simply have to do is we have to multiply both the numerator and the denominator by the square root of 3. As you know, the denominator is already 3. Remember, way back in probably 4th or 5th grade, you learned about equivalent fractions. And equivalent fractions, as long as we're multiplying anything by 1, it's going to equal the same thing. So here, we're going to use what we learned with the product property of square roots. We can do radical 10 times radical 3, and that equals radical 30. And then radical 3 times radical 3. Well, square root times itself is just itself. So the square root of 3 times the square root of 3 is 3. Okay, so continuing on, now we no longer have a square root in the denominator. So in our case here, the square root of 30 over 3 is simplified term. Okay. And radical 30, we can't reduce that anymore. So let's go on to our next problem. Both of these are in your book, so if you want to see another explanation, you can simply look at that. But again, here we've got radical 2 over radical 6. Now we're going to multiply by 1, but we're going to use radical 6 over radical 6. Anything divided by itself is 1. So we're just multiplying this by 1. So radical 2 times radical 6 equals radical 12 over radical 6 times radical 6, that equals 6. Okay? So now I'm going to actually take this square root and I'm going to write it down here, radical 12 over 6. And I have to ask myself, is radical 12 simplified? Well, if you remember, we actually did this problem yesterday, but if you remember, radical 12, if I take the prime factorization of it, I know that that is 4 times 3, and 3 is prime, so I can stop there, and I get 2 times 2. So the prime factorization of 12 is 2 times 2 times 3. We can take our square root pairs out here. 2 times 2 is 4, and the square root of 4 is 2. So this simplifies to 2 radical 3. So our answer then is 2 radical 3 all over our denominator, which is 6. Hopefully that seems simplified enough. Let's go ahead and I'm going to give you a problem that I would like you to try that same process with at home. So go ahead, try to solve this problem, and when you're done, go ahead and press play again and see if you got the correct answer. All right, let's go ahead and try this. So again, here we've got radical 12 over radical 5. So we're going to multiply both the numerator and denominator by radical 5. So we're really multiplying it by 1, but radical 5 over radical 5 is 1. But that's going to help us to simplify our denominator. Okay, so radical 12 times radical 5 is simply radical 60 over radical 5 times radical 5 is 5. And we have to ask ourselves, is 60 simplified? Or radical 60, that is. So radical 60 over 5. So I'm going to do right over here, I'm going to do our prime factorization tree. Hopefully you remember how to do this from, I know we started it in 5th grade. So we've got, and we do have some pairs here. We've got 2 times 2, so I like to write it all the way out. So this equals, radical 60 equals the same thing as 2 times 2 times 3 times 5. I've got a pair there that I can pull out. 2 times 2 is 4. The square root of 4 again is 2. So I've got 2 radical 3 times 5 here. I can simplify that to 15 all over 5. So if you got that at home, you're right on track. Let's go ahead and try one more. We've got radical 11y over radical 27. Now when you do this at home, I want you to take a moment and just relax. Don't fret about this variable. Follow the same rules that you know, and you should be able to get the correct answer. So go ahead and pause your video at home and go ahead and give that a try. Okay, so we know that we're going to have to multiply by radical 27. Okay, and I see here that I'm going to do 27 times 11, and we know that radical 27 by 27 is going to just be 27. So that's the easy part of this. So we know it's 27, but over here I'm going to quickly doodle down 27 times 11. I'll almost do this one without writing it down, but go ahead and write that. So I got 297. So this is going to be the square root of 297, but don't forget about the y. Don't forget about that y. Okay, so now we have to ask ourselves, do we have this in simplified form? Let's go ahead and check this. Okay, so I have to do a factor tree for 297, and I have to think about this. What goes into 297? You know, one thing I'm going to check real quick is does 9 go into it? I can do 9 plus 2 is 11. 11 plus 7 equals 18. And 9 does go into 18, so I know that 9 is one of the factors. And what's kind of convenient is I know 9 is a square, is a perfect square. And then 9 goes in there, let's see, 9 times 3 is 27. 3, so it's 33 times, yeah, 33. So that means that goes in there 33 times, and that's 3 times 11. So we know that the square root of 297y over 27 simplifies to radical 3 times 3 times 3 times 11 times y all over 27. And in this case, we know that we can pull out our pairs of 3 times 3. 3 times 3 is 9. We just talked about that. The square root of 9 is 3. So now this is going to be 3 over, and 3 times 11 times y is 33y over 27. Now you might think you're done there. You may have gotten that as your answer. That's great. But remember, think about fractions and think about what you already know about fractions. In this case, we've got a 3 over 27. That can reduce. You can reduce that by dividing both the 3 and the 27 by 3. and leave you with 1 there and 9 here. So our simplified version here is 33y, square root of 33y, all over 9. Now you can't, just so you know, you can't take 9 and reduce it with 33, or if let's say it was 27, we couldn't simplify it there. It has to be outside of the square root in order to simplify it. Okay, moving on, go ahead and try this one out. Go ahead and press pause and I'll give you I'll start up here in a few seconds. All right, so we have to multiply both the top and the bottom by the square root of 8 and the square root of 8, and say the numerator, the denominator by that. So I've got 24, square root of 24 over 8. Okay, and then we have to just ask ourselves, is 24 simplified? Is the square root of 24 simplified? And just like we learned yesterday, we're going to do 8 times 3 here, I guess, and 4 times 2. Boom, I know I've got a square root right there. I'm going to write the square root of 24 over 8 as 4, square root of 4 times the square root of 3 times the square root of 2. Okay, 4 times 3 is 12, times 2 is 24. It's over 8, and then I know that I can pull out the square root of 4 in this case, and that's 2. So 2, 3 times 2, and equals 6, and that's over 8. Again, I can simplify these right here by a 2, and that's going to leave me with 1/4 left over. So I'm going to have the square root of 6 over 4. And that's your solution. Let's leave it at that, and hopefully I would like you to go ahead and try your homework. I've got it up here already. I want you to go ahead and try your homework, which is right here. It's numbers 9, 10, 27, 29, and 31. You can either try that at home and come with questions, or we can practice that in class tomorrow. Have a good evening.